Hello, my name is Rob Warner. I work for Availity, and there's some contact information for me here. We'll be looking at code that's all in this repository. So if you wanted to clone that repository and follow along, you could. This presentation is also in the repository. It is written in Markdown and displayed using an application called DeckSet, which is not free. So if you don't have it, you probably aren't going to download it just for this presentation. But the presentation is written in Markdown, so it's easy to follow along as well. So we're going to talk today about building microservices in Go using GoKit. Now, how many people in here have used Go, the language Go at all? Okay, so we got a few people. How many have heard of it? Excellent. And how many have used GoKit? All right. So we're going to step through a lot of code samples. I think you'll find that there'll be some things that look a little strange. We'll walk through those things. There'll be a lot that looks familiar. So we're going to introduce GoKit. We're going to build just a CLI CRUD app. We're going to add an HTTP layer to it. We're going to add a GRPC layer to it. And then we're going to build a Node client. And that'll be the opportunity for all of you to giggle at my Node skills, because they're not very good. I saw this tweet the other day. Finally getting to try out Golang. It's like JavaScript and C had a sugar-coated baby. Well, that was kind of funny. As you're looking at C code, you'll notice a lot of, at Go code, you'll notice a lot of things that look familiar. It was developed at Google by some Unix folks, and it is a C-like syntax. It's been referred to as C 2.0. Think of C with some better syntax and garbage collection. One tip for learning Go, make sure that you Google Golang instead of Go. There you'll get a whole lot of better results. GoKit calls itself a toolkit for microservices. It was written by Peter Bergon. Right now you might know that in the Go world there's sort of some controversy about dependency management. Peter is part of the team that wrote the DEP tool. So he has some serious credentials in the Go world. But it is a collection of tools. It's not a framework. It's not prescriptive in that you follow this recipe and you're done. But rather it brings together a collection of tools. It separates your concerns. And so it's not initially apparent how to use the toolkit, but as you get into it and you understand how it's working, how it's separating concerns, how the layers of your application work together, it becomes very powerful. And I hope we're able to see that today. So this is an overview of the application we're going to build. We're going to have a database here, right there, that's going to hold a collection of players. We'll have a structure, a player structure that contains all the information about a player. Then we're going to create a collection of services based on this service interface. And none of this here has anything to do with GoKit. So one of the things that makes GoKit powerful is it separates GoKit specifics with just your business logic, your business rules, your database access, all of those things. So we create this and then we layer the GoKit on top of it. Right here you can see the endpoints component. We'll look deeply at endpoints. Endpoints are the bridge between your application and GoKit. Because what we're able to do, and we'll do this in this presentation, is after we create our endpoints, we can create an HTTP transport layer so that we can surface our code here as REST endpoints. We can also surface that here as a GRPC transport using GRPC calls. And we'll go into what GRPC is. How many of you are familiar with GRPC? Okay, just a couple, but I think you'll, if you've been in the industry a while, you'll see a lot of familiarity in what GRPC is. So that's an overview of the application we're going to build, and let's dive in. And now you understand why a grown man is wearing a football jersey at a computer conference. We're big Jaguars fans. I'm from here in Jacksonville. I was watching their preseason game last Thursday night, and my 14-year-old, who is type A, a gymnast, very competitive, has to measure everything, said, "It's not like this game even matters." I said, "Okay, you're right, it's preseason." But then my 17-year-old, who was an artist and a dreamer, said, "It's not like any of them matter." So I understand that it takes all types to make the world go round. So even if you're not a Jaguars fan or a football fan, I hope you're able to see past that and enjoy the technology and understand how it can be used in your specific situations. But we're going to create this table, or actually I've already created this table in a Postgres database. I've scraped the Jaguars player roster from their site and loaded it into that table. It's current as of before Thursday's game, and I don't know if they've added or cut anybody, but we're going to be able to work with the Jaguars roster. We'll be able to list players, we'll be able to get a specific player, we'll be able to save a player, we'll be able to delete a player. So our model, this is Go code. Go is based around structs. You do not have classes, but you do have structs. If you're familiar with C structs, these are, you have data. We've created a data type called player, and it's a struct that has these fields. They're all capitalized because they're public. In Go, things that are capitalized have an initial capital letter are public. Things that have an initial lowercase letter are private. These are the data types. We have an int, a bunch of strings, another int, and another string. And then these tags here that we're able to put on our structure are used by various pieces of code to know how to interact with our data. So our database layer understands a tag called DB, and this is the column in the database. And our JSON marshalling and unmarshalling uses these tags to understand how to marshal these types, what names to give those fields. Questions on that? So this is a function that we've written to list our players. Can you see that at the back? Okay. So this is a database connection. We have a function that lists players that takes our database connection. It takes a position. One of the things that's a little startling for people first time they see Go code is the variable comes first and then the type. So the way we read this is a function called list players that's public, takes a database connection, a position that's a string, and then the return type, which is an array of players or a slice of players, and an error. This is very idiomatic Go code. You can return multiple values. You can return tuples from Go functions. And it's idiomatic to return the data you're interested in and an error. And that's how errors are typically handled in Go. So what we're going to do is we're going to create an array of players. We're going to create an error. If the position is an empty string, then we're just going to select from players, order by number, the uniform number, and put that all into our players array. Otherwise, we're going to say where position equals whatever they passed in. So if we get an error doing our database query, we're going to return no players. We're going to return our error. If we get no players at all, but there was no error condition, then we're going to say, okay, we're going to return a SQL error that there were no rows found. Otherwise, we're going to return the players that were retrieved and nil for the error. Questions on that? So, as you can leverage your expertise with C# or with JavaScript and so forth, and the syntax is very familiar. Now we create an interface. This is our service interface that contains these 4 functions: list players, get player, save player, delete player. Context is a structure in Go that is, it's kind of like a thread local in Java. I would tell you what the kind of is in C# if I knew, but I don't. But what's that? Okay. So it's kind of like a thread local. It's not the same thing. And if you stood in front of a Go purist and said, oh, it's kind of like a thread local, they'll probably say, no, it's not, and tell you all the reasons why it isn't. But this will allow us to pass the context of our round trip through our code. Then we pass variables and we have return types. Now, adherence to an interface in Go is implicit. It is not explicit. We don't specifically say, my structure is going to adhere to this interface. So it's a little bit like duck typing, except it is enforced at compile time, not at runtime. So if we try to pretend like something adheres to the service interface and make calls on it, it won't compile. So we've created our database layer, we've created our service interface. Now we're going to actually create an implementation of that interface that uses our database layer and gets the players. So we're not going to be using the context here, so we just put an underscore because unused variables get flagged while we compile. We take our position. Here is our service struct that creates the database connection, stores the database connection. And we're just going to call that list players function that we showed earlier, passing in the database and the position. We are going to say, all right, we don't want to bubble up that this is SQL. We're just going to say we've created an error called error not found, and we return the players. So this is all pretty straightforward, being able to list players. So we've created this code, and now we run it. So in this repo, I have tags for each of the steps. You can see we're on tag step 1. So we make quick, we run roster, and so we passed in position QB. We see that the Jaguars have currently 3 quarterbacks on their roster. Questions on that? So all of this is pretty straightforward. We haven't done anything about GoKit. We have created a command line application that gives us our quarterbacks. Step 2, we're going to add a logger. GoKit does provide a logger. In this case, we have used the GoKit logger, but you could use any logger that you want. But what we're doing is we're chaining our logger service to our database layer service. What does this do for us? What this allows us to do is chain together all of our services into one pointer that we're going to pass around. And we can do logging, we can do instrumentation, we could do security, all wrapped together in this one service that are chained together. So when we create this, we are going to send in our logger and a next service, and that next service is going to be our database service. So we've wrapped those together, and it's going to look like this. So here we just have defer func. Anytime we defer something, that means this function will run when it falls out of scope. So all we're doing, this is kind of like an IFI in JavaScript, where we are going to, this function will start, it will do all the work here on the next layer, and then it's going to log things like the time that was taken. And here's how we chain those together. we create our new database service, and then we create our logging service, passing in a new logger and our database service. So that way, when our call comes in, it will call our database service here, and then it will log what happens. Questions on that? So when we run that, we can see that we've added some more information to our output. We log that we've created our logger, that we've connected to the database. We're using log format here, our player service. Now we're actually listing players, and this is where we say, okay, it took us 1.6 milliseconds, almost 1.7 milliseconds, and it lists out our players. Questions on that? So you can imagine you've created any sort of service that doesn't have anything to do with GoKit. Now you want to surface that in various contexts. You want to create a REST service for your browser clients to call, but you also want to expose a GRPC service so that your other services can call your service, and it'll actually be faster that way. So the endpoint in GoKit is really that bridge, and it's very simple. It is a function literal or a lambda that takes the context, takes a request. Now this is called an empty interface. We saw what an interface is. An empty interface is an interface with no functions on it, which means every struct adheres to an empty interface, right? And then it returns a response that also is an empty interface and an error. So this simple function here called endpoint is intrinsic in GoKit and creates that bridge, because we can take that endpoint and hand it to various transport layers that GoKit knows about, or other layers that we create that know about endpoints. And that, in that way, everything from endpoint forward doesn't have to change. The only things that have to change are the various transport layers. So in our case, we're going to create a structure of all of our endpoints. We're going to create a list players, a get player, a save player, a delete player endpoint. They're all of type, this is the package name, by the way, endpoint. So endpoint.endpoint. So these are all functions, right? And we create them by passing in our service. Remember, that's our service that has our logger wrapped around our database. And we call these functions that we're going to look at an example of. And we're going to say, all right, return, this is the address of operator. So return a pointer to an endpoint structure that contains these 4 endpoints. That way we can pass our endpoints around our application as a single structure. And let's look at what one of these functions looks like. First, let's look at this first and then the previous slide. I think it'll make more sense that way. So we have a make list players endpoint that takes our service, which is our logger wrapped around our database service, and it returns an endpoint, which is a function, a lambda, and we return a function. You can see that method signature, function signature of our context, our request, our response, and an error. And what we'll do is we'll take in our request, and this is kind of like a cast. It's called a type assertion. We will take that into a format that we need, our list players request. We will call our services list players function, passing any position that was passed in the request. And then if there's not an error, or if there is an error, then we'll return a structure that contains the error. Otherwise, we'll return our players. Well, what are these list players requests and list players response? These are our data structures that our endpoints understand. We have a list players request that knows about a position, and a list players response that knows about an array of players and an error as a string. Now you might think, well, why aren't you using HTTP codes for your errors or HTTP sorts of status error messages? Well, at this point, we're not HTTP anything. We don't care about HTTP. What we are is just data, and we're saying that our response is going to contain a list of players and an error string. Questions on that? So, we've created our endpoints. Remember that central box in our diagram. Now we're going to add an HTTP transport. This is where it gets fun. GoKit provides an HTTP transport layer. You can see that what we're doing is we're passing in that endpoint structure that we created. We're passing in a logger so that our HTTP server wants its own logger, right? It can log any server errors. It can encode the errors. But here we create a new server, a GoKit HTTP server, and we say, this is the endpoint to call. Here's how to decode the HTTP request into the endpoint request. Here's how to encode from the endpoint response into an HTTP response. And they'll be very similar, but there will be subtle differences. And then we have handlers for each of our different functions. I'm just not showing those here. But we'll have a get players handler, we'll have a delete players handler, we'll have a save players handler. Well, what do these look like? Well, we already know what our endpoint looks like, but how do we decode an HTTP request into a request that our endpoint knows about? Well, we just look at the query string and we get any value in the position variable. So that way somebody can say, call our HTTP server question mark position equals whatever. And then for our response, we'll get back that list players response that our endpoint gives us. If there's an error, if there's not an error, then we're going to call this function, encode HTTP response. We're going to say we got a 200, HTTP status OK, and we're going to write it to the response writer. Otherwise, we are going to encode an HTTP error and return nil for the error. Questions on that? Let's see that in action. Well, first we have to bind it to actual URLs. So we create a router and we say, okay, when we get v1 players, we're going to call that list players handler that we created when that's called with get. So here we've created all of our routes, our HTTP routes, and we've in essence bound them to endpoints that we've created. So when we run that, we can see that we have created our HTTP transport and we've started listening on 9090. So if we now run a request, we can see that we get our data back. Let's go back to quarterback so we get the same response. So we can see these same three quarterbacks that we now are getting through HTTP. And we get a JSON response, but again, this is going down to our original service that we created that hits our database, returns our data, and we're just sending it back via HTTP. Questions on that? Yes.
You are not connecting to localhost. You are not doing a postman. You just did a CLI.
Right. Well, I use BAT, or you could use curl.
Oh, okay.
So I'm making an HTTP call, but to the server running on my computer, and actually Postgres is running on my computer.
I see.
Yeah. All right. So we've created a service. We've wrapped an HTTP front end on it. Now we want to do GRPC. GRPC is a remote procedure call created by Google using what's called protocol buffers. Have any of you done any sort of remote procedure calls, like Java remote procedure calls or Corba, those kinds of things that, in essence, what happens is you create...
Memory lane.
It sounds painful, doesn't it? I think this one's better. But the idea behind it, behind most of these RPC sorts of things, is you create some sort of definition, specification, interface definition file, or whatever it is. And you create a file that describes what these functions are, and then you run some sort of compiler against it that generates code both for the server and for the client, and then you use that code in your application. So what does that code do? That code has all the networking stuff inside it, so you feel like you're just making local calls because you're calling this generated code, and then the generated code makes the network call. It's responsible for getting the data back and marshaling it back into your application. So it's an attempt to hide the complexity of a remote procedure call and allow your code to just be making local calls. So here's the website that talks about protocol buffers. That's the specification language that GRPC uses. You need to install the ProTalk compiler that understands the protocol buffer specification language. You need to install a language-specific plugin for whatever language you're working with so that it can generate code, in our case Go code, for your server and your clients to use. And then you create your .proto file. So let's look at what that kind of looks like.
You can create for multiple languages?
Yes.
So in this case you did Go, but you want to distribute the proto file for multiple, say C++, C#.
Right.
Somebody that likes to do PHP. It's a masochist over here.
Now I don't have memorized the list of supported languages. I don't know off the top of my head if it supports PHP, but we're actually going to look at a node client that's going to call our GRPC server. And so we'll be generating code in Go for our server and generating code in Node for our client. And they will talk to each other via GRPC. So in our protocol language, we create a service, and you can see that this is pretty readable. We have these 4 remote procedure calls that should look familiar by now. Our list player, our get player, our save player, our delete player, that each of those takes a request. We haven't yet defined what those look like, and returns a response. So this is part of our proto file that defines our service. What are our 4 remote procedure calls that we support? Now we're going to create a message, which is a player, and you put the type, the name of the field, and the order that those are supposed to be marshaled in as they go over the wire. So we've created a player that matches the fields from our database, matches the fields from our service. Now you remember each of those calls takes a request, some sort of request object and some sort of response. And in this case, our list player's request takes, in the first position, a string called position. So that'll be where we pass quarterback or cornerback or running back or lineman or whatever. And then our response will have a repeated message called player, meaning that we have a list of players, and that'll be in the first spot, and in the second spot we'll have a string that has our error. So one of the things you notice is that you start to fall into a lot of repetition with GoKit, and there are some tools that we'll talk a little bit about that help with that. But with gRPC, we're going to be translating from our gRPC spec to our gRPC objects or data structures, and then to our endpoint data structures, and then to our service data structures. So here's more information about gRPC. Here's a tool I found that reads a protocol buffer file and acts as a client. So you don't have to create a client every time you're creating a gRPC service. You could quickly spin this up to run tests against your gRPC server. It'll read in your file, and you can make the calls as you're doing development, and it's a very handy tool. So, back in our Go code, we are going to create a structure, gRPC Transport. It mirrors our HTTP transport, but we're going to have 4 gRPC handlers: list player, get player, save player, delete player. We're familiar with those. And this is how we're going to create it. From our code, we're going to create a new gRPC transport, pass in those same endpoints. We get a lot of mileage out of our endpoints, right? We pass those in our logger. We create, this should look familiar with our HTTP server. Now we have a gRPC server option that we create a logger. And then we create our structure where the list players is going to say this, whoops. Here's our endpoint that we've already seen. We're going to look at these decode and encode in a minute, but again, this is taking the data structure from gRPC into our endpoint data structure, and from there we know how things work. So this is an example about how we decode a gRPC into our endpoint. We have this package called PB. We've called it PB for protocol buffer. And this is a generated structure that was generated from our protocol buffer file. And we just say, okay, we're going to return one of our endpoint list player requests that we saw earlier, pulling the position out of our protocol buffer request. And that's how we get the data from gRPC, send it to our endpoint. Now here's how we send it from our endpoint back into the gRPC layer. We get our list player response back from the endpoint. We make a slice of players, or an array of players, the same length as our endpoint's response of players. We have a helper function that's going to translate our endpoint players into gRPC players. And then we return a gRPC generated response. Questions on that? Now this is some of the code that gets generated for us. There's a whole lot of code. Some of it you don't want to look at because it's confusing, hides a lot of details from you. But the gRPC protocol buffer stack will generate for us this interface called player server that contains these remote procedure calls. So you can see how that maps to our protocol buffer file. And it generates this function called register player server that takes one of these and one of these, right? And what does that look like? We create our new gRPC transport layer, passing in all of our endpoints and a logger. We create one of those servers that was generated for us, and then we call that register player server, passing in the server, and our transport structure. And then GRPC, the generated code, will take care of calling into our GRPC transport so that when one of our endpoints gets hit, then, for example, list players, that it's going to send it to this endpoint, first decoding our request here so that our endpoint understands it, and then encoding the response from our endpoint so that GRPC understands it. So, here's an example of our GRPC list players call, because GRPC doesn't understand our endpoint. It's going to call in here, and we're going to call that list players serve GRPC and return a GRPC response. So let's run this. So we're going to check out step 6. Oh, no, we're not. Yeah, wrong repo. We didn't. We don't check out step 5 because that is just added the protocol buffer. There wasn't anything new to run. Okay, we're going to run our GRPC server. You can see that we still have our HTTP server listening on port 9090. We also have our GRPC server listening on port 9091. Now, this is the part that I get nervous because I'm going to show you my node code, but at the very least it will amuse you. Okay, so these are things that get generated from our protocol buffer file. I've copied over the protocol buffer file into this project. In my package.json, I have in the script section to run proto, and that will generate these files. We also have the GRPC NPM library, and we're just going to add a toString to the player prototype, which is generated code that's just going to show information about our player. We've got our function main that is going to create a new GRPC client. We say, okay, you're going to connect to a server running on localhost 9091. We're going to be totally insecure, no credentials here. All right, we want you to list all of the quarterbacks, all of the power forwards, the player with the ID 12, and the player with the ID 500. That's so you get to see what errors look like as well. And so our list players function is going to create a new list players request. This is generated from the GRPC. We're going to set the position to whatever position we passed in, and then we're going to call our client list players, passing in the request, and we'll get an error or a response, and we'll log it. Get player looks awfully similar. We pass in the client and an ID. We create a get player request, we set the ID, we make our call to our GRPC client, and it's going to handle doing all the communication, and if we get an error, we log it. If we get an error from our server, we're going to log it. Otherwise, we're going to show the player. Then we call our main function, and that's how this works. So when we run that, we can see that there are no power forwards in football. That's why we get an error back. the player with the ID 12, you can see that this ran all of this asynchronously. It got the responses asynchronously. That's why they're not in a particular order. That's CJ Rivas, who's a rookie out of Marshall. Here's our 3 quarterbacks, and there's no player with the ID 500. Questions on that? That's the repo for the node code, by the way. So where do we go for more information? There's a book called Go Programming Blueprint 2nd Edition by Matt Ryer. He's got a good section on GoKit, and it's very helpful. I also recently found Package Main is a channel on YouTube that has just started a series on GoKit, or at least they say it's going to be a series. I saw the first one. That's the URL for it. You can either take a picture of it or you can clone that repo, and you'll find that in the presentation. And this talks about a command line tool that sort of has the flavor of rake, generate, or things like that, that will generate some of the GoKit layers for you. And then here's more information about GoKit. In GoKit, they have some examples, quite a few examples, about 5 or 6 or 7 of GoKit code that shows how to create these things, how to map these to HTTP, to gRPC. And that's the end. What questions do you have? Yes?
So I'm wondering, like, for like authorization, authentication, is that something you handle at the endpoints, on the transport mapping, the decode, encode? Where does that happen?
That's a very good question. So generally, the way credentials come in to your service is transport dependent, right? So HTTP, you might have an authorization header, you might have a cookie, the JOT might be coming in an authorization header or whatever. And then when you actually enforce the security, that's usually not transport specific. So generally what you do is so let's look at the code a minute. I think this will help us see. So here's where we're taking our endpoints and we're mapping those to handlers. Well, what we would do is GoKit allows us to chain together endpoints. So rather than just pass in this list player's endpoint here, we create another endpoint that pulls the data out of the request or out of the headers or wherever it is in HTTP and wraps around this endpoint. So that way we pull the credentials. gRPC, you'd create stuff in the GRPC transport that pulls the credentials out. And then probably what you would do is wrap your service in the actual authentication layer. So your endpoint will pull out the data, stuff it into the context probably, and then in your service, you would pull it back out of the context and say, okay, who is this user? They've been authenticated, or maybe they haven't been authenticated. You authenticate the user. Maybe you do your authentication in one layer in the service and then create a new service that does the authorization. And then you would return that service from here. So again, you're just passing that around as a single pointer. Does that make sense?
Yeah, cool.
Good question. Other questions?
And you said that YouTube channel had a tool that would kind of generate some of that boilerplate code.
Right.
I've used GoKit before, and that's the one thing that I didn't like about it was the kind of the repetitive boilerplate around creating your transport layers and your endpoint. So it's good. I was going to ask if you knew of a tool, so I'll check
Right.
that out.
And apparently GoKit itself is working on a tool,
Okay.
but it's not out there yet. This one is. I don't remember the name of it. But you know, if you're developing just a website that is going to serve up web pages, you're probably not going to choose this tool. You might choose something like Go Buffalo if you want to do Go. I don't know if you've heard of Go Buffalo. It's kind of like Rails for Go. But if you're creating microservices and you want to be able to use various transport layers, this is an excellent tool set for that. So,
Why I would like to use GRPC?
because it's faster. It is faster than HTTP.
It says it's 10 times faster with 30% less resource consumption. I just knew this.
So Google might be giving some propaganda there because they created it, but
It looked like a legit site.
but you can imagine. Okay, so we want to still use client browsers to access our REST services, but if you're also calling another service from a service, rather than take the overhead of HTTP or HTTPS, use GRPC. Well, thank you very much for coming out. Again, I work at Availity. We have, I talked to, you've seen Greg around probably. He's our head recruiter, I think. He's about 6'6", you can't miss him. Told me to mention that we have the meetups at the Availity office. We're moving to a new office in a couple weeks. So the September meetups will be in the new office. We're really proud of it. We'd love for you to come by and check it out. It's really cool. Like any other company, we're always hiring. And we do a lot of Node, we do a lot of Java, we do a little bit of Go. I'm trying to make it more Go than we do now, but we're actually using GoKit in production and getting great results from it. Other questions? Oh, by the way, Go is cross-platform. It's compiled, statically linked, so you get a single binary that is platform specific. So on my Mac here, I could create a Windows binary, a Linux binary, and a Mac binary. It's a great tool for doing anything cross-platform.
And if you want to do multi-threading as well.
Doing threading as well, yeah. So Go has concurrency built in. We'll look at that just really quickly. Anytime you see Go func, then it's running that concurrently. And so what we do, and we communicate across concurrent functions using channels. So we make a channel, we start our HTTP transport, so we create this anonymous function and run it asynchronously, call it immediately for HTTP, also for our GRPC. So concurrency is very much built into Go and it works really well. Well, thank you all for coming.